In the name of Allah, the most gracious, the most merciful, praise be to Allah, and peace and blessings be upon the Messenger of Allah, our Master Muhammad, and upon his family and all his companions. Now, after finishing the general discussion in the first episode and talking about topic in the second episode, we begin with a new episode, a new challenge, and practical information that will benefit you in the job market about the scientist Rogowski solved one of the biggest problems with CTs, which is the saturation issue. He invented a CT that doesn't experience saturation at all. He designed a CT that has an input current on the primary side, but on the secondary side, it has an output voltage instead of current. This means it doesn't saturate like other CTs, and this CT can handle high currents up to 5 kiloamperes. ABB applied Rogowski's idea to its relay, the Reliant 542 Plus, designed to measure overcurrent using voltage. To test it, a Rogowski CT connects to the testing device, injecting current and converting it to a matching voltage for the relay. For other meters or relays, connect the Rogowski CT through special amplifiers. The Rogowski CT is an optical sensing CT. Why not address VT saturation like CTs? Saturation usually occurs with volt current. High current can lower voltage, but voltage drops may not affect VT significantly, so saturation is less common, though possible with overvoltage. But there's a question. Why didn't we address the saturation issue in VTs, voltage transformers? That's because saturation problems occur with volt current. If I have voltage, this voltage creates high current lowering the voltage. So when there's a drop in voltage, it may not affect the VT and it might not saturate. Therefore, saturation issue is not widespread in VTs, though saturation can occur in VTs if there's an overvoltage. Now, a new problem with CTs, which is the issue of opening the secondary circuit of the CT while energized or during line operation. Why is it prohibited to open the CT circuit while the line operates? When he has a decrease in voltage, this voltage may not affect the VT and may not stabilize. Therefore, stabilization problem is not widespread in the VT, though stabilization may occur in the VT if it is overvoltage. Opening the CT secondary circuit while energized is strictly prohibited. When primary current flows through the CT, it creates a magnetic field. This field generates a force pushing flux into the core. Flux flows in the core, intersects with the secondary winding, creating voltage, generating current when load is connected. This current creates a field opposing the original, reducing its value. If the circuit opens, no opposing force counters the original field, concentrating current in the core, increasing voltage across terminals. When the primary current flows through the CT, it creates a magnetic field, generating a magnetic motive force that pushes the flux into the core. The flux flows within the core, intersects with the secondary winding, and creates voltage and current in the secondary. This creates a new magnetic field opposite to the existing one, reducing its value. If the circuit opens, there's no opposing force, so the original current concentrates in the core, significantly increasing voltage across the terminals. This high voltage is dangerous for the transformer and maintenance workers. Then it creates a magnetic field that is new and opposite to the existing one, which reduces its value. In the case of opening the circuit, there will be no opposing force to counter the original one, and as a result, the original current will concentrate in the core, leading to a significant increase in voltage across the terminals. This high voltage poses a danger to the transformer and the people. Those who experienced this had their hands burned like holding a flame. If you must remove the relay when line is live or error, short CT secondary terminals before relay removal. If removing the relay, short CT secondary terminals first. This keeps current flowing, opposes primary MMF, and prevents voltage rise. VT is parallel, CT is series. Before removing it, it's important to ensure that the design is clear and the features are easy to operate, providing safe and reliable handling. Current in short circuit prevents CT secondary voltage rise. VT is parallel, CT is series. Primary CT current is constant. Primary VT current depends on secondary load. Secondary load generates primary current. Without it, both disappear. MCBs or fuses protect VT secondary from short circuits or high currents. Opening CT secondary or shorting VT secondary is dangerous. This indicates that the current in the primary CT will be present whether the load is connected to the secondary or not, while the current in the primary VT depends on the presence of a load in the secondary. If there is a load in the secondary, a secondary current will be generated, which in turn will create a primary current. If the load is removed, the secondary current will disappear, and consequently, the primary current will also go away. Therefore, there is no danger in opening the VT secondary circuit. It is essential to place MCBs or fuses on the VT secondary circuit to protect it from short circuits or damaging high currents. Avoid opening the CT secondary circuit or shorting the VT circuit. A resistor parallels the CT secondary circuit for all phases. If opened, voltage rise blows the resistor, shorting to protect the CT. Prefer ring lugs in CT terminals to prevent loosening and open circuits. During relay testing, the test switch should open the VT circuit and short the CT circuit. If DAR test DD opens, municipal rise will explode the resistance. So, the resistor becomes a short circuit. It's better to use ring lugs in CT terminal. Place test switch in test plug to open VT secondary and short CT secondary. We found VT wires connected to CT location in test switch and CT wires to VT location. This causes an open circuit for CT and short for VT, very dangerous. Highlights importance of testing before operation. We found that the VT wires were connected to the CT location in the test switch, while the CT wires were connected to the VT location in the test switch. This means that when the test switch is placed inside the test plug, it will create an open circuit for the CT and a short circuit for the VT, which is very dangerous. This highlights the importance of testing and commissioning before operating any station. Inspiring the nation's revival.